So the x component of a force can be found by using F sine theta, and the y component can be found using F sine. Whoa, do I have both signs up there? That is crazy. That's cosine. Okay. So the x component is F cosine, the y component is F sine, and that's when the angle is measured to the horizontal. That's important. When the angle is measured to the x-axis. So what's the first step in solving a force question? Before you can sum them, you got to draw that free body diagram, okay? So here is the knot, or here's where I'm going to orient all my forces. And there it is right there. So what's interacting with this intersection between the strings and the block? We've got a rope here. I'm going to call that rope 1. You got a rope here. I'm going to call that rope 2. So the ropes are interacting with the knot. And what's this block doing? It's pulling down on it, right? Okay. So let's draw the forces acting on it. Let's go around. So what does the block do to it? Pulls it down. That's the gravitational force. What does the first string do to it? Pulls it left and up to give us this angled force. That's right. And I'm going to call this one F tension 1 because it's for my rope number 1. You can label it whatever you want to label it, as long as it's not ugly. Okay, so then what about this second rope over here? What's it doing? It's pulling it over and up, so that gives us this angled force again. So we can't add these two together because they are in wacky directions. So we need to figure out what is the over and what is the up, and what's the over and what's the up. So each one of these has an over and an up and an over and an up. Each one of them has an FT1 in the x direction and an FT1 in the y direction, an FT2 in the x direction and an FT2 in the y direction. All right, our next step is to sum the forces. Now we have forces that are in the x direction and forces in the y direction. So to do this, I go around the axis. So you can make yourself a reference coordinate system. So let that be your horizontal or x, and let this be your vertical or y. And if this is 30 degrees here, then this right here is also 30 degrees. 30 degrees between the horizontal and the rope, 30 degrees between the horizontal and the rope. So this one would be 60 degrees because there's 60 degrees between the horizontal and the rope. So any horizontal and the rope would make 60 degrees. Alternate interior angles or some sort of geometry like that. Okay. So then I need just the x component. So is FT1 pointing or have in the x direction, the y direction, or both? Both. It's in both directions. So it has an x component. Now is that x component positive or negative? Is it pulling it left or right? Right here in the x direction, we go over and then we go up. So is the over positive or negative? It's negative. So it'll be a negative. Now, this F right here represents whatever is on the force arrow. So that'll be an FT1, and then it's the x component, cosine of 30 degrees. What about FT2? Does it have an x component? It's positive. It's positive FT2, and then it would be the cosine of 60 degrees. Does the gravitational force have any over? No, it's just down. Is that all my forces then? Are those all my forces? And that equals 0. All right, so now let's do the y direction. Does the FT1 have a y component? Yeah, is it positive or negative? It's positive. What about FT2? And what about the gravitational force? Is it in here in the y direction? It's the negative Fg, and that's all. So when I sum the force, it equals 0.